Okay, so we're in this last unit looking at exponential and logarithmic functions. So I've been holding online class sessions, but I know some of you just aren't able to participate in those. So I thought I'd go ahead and do some videos similar to what we did in the class session. So the main thing I'm doing here at the start is just kind of giving you enough background where you have a sense of what it is we're talking about and how it's different from what we've done before. So the document I'm working on right now, this is in document sharing. Okay, so you can download that if you have a printer and want to print it, and you can take notes yourself. Also, I went ahead and posted completed notes, but a lot of times it's good if you're writing it as we're talking because it just helps you make sense of things. So I wanted you to see the difference between the three functions right here. They're very different. And it's the location of the x that's different on this one and this one. See how with the first and the second, the x is on the same line as the equal sign? You know, it's the base of the exponent there. Here, it's just 2x. Here, it's x squared. Here, it's 2 raised to the x power. So the x right here is an exponent, okay? And I don't know if you remember, but the 2 was called the base. Okay. Well, when the variable is here, when the variable is in the exponent area, that means you're dealing with an exponential function. Okay. These other two are polynomials, special types of polynomials though. This one's linear and this one's quadratic. Okay, but those are both polynomials. All right, so the next three problems I give you where we're not working out right here, but I just wanted you to know that models like this is an exponential function. This particular problem has to do with a radioactive decay. So it's like you had an element that was radioactive from a nuclear power plant, and this model would let you know how much of that radioactive element is remaining as time goes on, because it starts deteriorating and then it loses its radioactivity over time. But the main thing I want you to know is that exponential and logarithmic functions are useful. We're not really going to work these right here, right now. So that one's a decay problem. It would look like that, kind of comes in and then it starts leveling off, okay? And this would be exponential decay, okay? So in this case, it's radioactivity that it's losing its radioactivity over time. But this model also works good for like medicine in your body. Like if you take a drug, over time it gets metabolized, so you start losing it from your system, and this is kind of what it does. Kind of lose it rapidly and then it sort of levels off. And a lot of times you're waiting until that safe point at which, you know, the patient is recovered. You know, they have to have less than a certain amount of the medicine in their body to be recovered. So yeah, so that's exponential function, that's exponential decay. Okay, this one is actually going to be part of a little mini project you're going to do where you just work these problems later. And what's going on here is you have money that's been invested in bank accounts that take care of the interest in different ways. This one pays you interest twice a year. This one pays you 4 times a year. This one pays you, like it says, continuously. And so what happens to your money is that it grows over time. And the more often they compound it and the higher the interest rate, the faster it's going to be growing. So there's 2 things that affect the growth of your money. Well, 3 things. How much you invest initially, okay? How often they pay you interest, and what the interest rate would be. So it's going to look something like that, hopefully, and that is exponential growth. So your money is growing over time, and it grows more and more rapidly as you earn interest on your interest. And then one quick look at an logarithmic function. This right here is a button you've been seeing on your calculator, but we haven't had to use in the past. Okay, that ln right there, we'll find out means natural log. It's a natural logarithm, really. Okay, so this is a logarithmic function. And so these functions do something differently. ln function actually grows over time kind of rapidly, but then tapers off this way, okay? Where here we got it growing rapidly in the beginning, slowly in the beginning and then getting more and more rapid. Here it's rapid in the beginning and then getting slower and slower and slower. Okay, so that's kind of what a logarithmic function looks like. Okay, and that's what this is right here. So they're useful for different models as well. This one dealt with temperature in a car, the degrees. It gets really hot really fast, and then it reaches that really hot temperature and just kind of stays there. Okay, levels off to what the ambient temperature would be. All right, so the next little piece I want to do as part of this video really just depends on you having a calculator handy. So if you don't have it with you right now, go get a calculator, because what we're really doing on this part of the exercise is just using our calculator to figure out the values of these different things, okay? All right, and I think when I posted my notes on this, I can't remember if I posted the one that had the E's in it, or I might have posted, instead of that number 7, I might have had one with like a 4 in it. Can't remember now, but I think I changed this from what I posted originally. All right, so we're just learning about this. This material is not hard, it's just new. So you just got to have an open mind about it. All right, so on your calculator face, you have the LOG button. LOG is what we call the common log or logarithm, okay? And the button on the face of your calculator, LOG button, is this one. And it's understood to be log, what we say base 10 is how we read it. And so it has like a little subscript in reality, but you just don't have to write it because it occurs all the time. So if it is log base 10, you just don't have to write that. It's kind of like, with a cube root, you have to put the index so people know it's a cube root. But with a square root, it means that, but you typically don't write it that way. You typically just write it like that. Because it's so common, we get lazy and we don't have to write that every time. Same thing with log. And then like in this model up here, natural log is also a logarithm, but it's a different type. So it's kind of like these are all roots, but you can have different types of roots, right? Roots are not logarithms, but I'm just trying to make the analogy that it's kind of like that. So there's a lot of different types of roots with various indices. They're all the same type of thing, but the functions are slightly different. Same thing's true with logarithms. You can have logarithms of all sorts of different bases, but these two right here are the two that you work with the most. And ln is the natural log, and that's where the n in ln comes from. And it's log base this number e, log with the subscript of e. And e is kind of like pi. E is like pi. Okay. Both of them are irrational numbers. That's what goes here, irrational. They have decimal forms that go on forever. So instead of doing an approximation, they've just named them so that that's the exact answer. But it's a decimal that doesn't stop and doesn't repeat. And these buttons on your calculator. So do you see where the log button is on your calculator? Mine's kind of under the second function key. So it's like a little second function key sitting on my calculator. And then log is right below it. And then below that one is ln. Okay. Well, if you look above the ln button, you'll have the ln button sitting there. And on my calculator, right above it as a second function key is e to the x. That's what you can use to figure out what e is. If you type in e to the first, so do second function ln, and I'm just trying to show you that e is about 2.718 if I round to 3 decimal places. Okay, so all 1 through 10 are doing, all they're asking you to do is try these on your calculator so you know where the buttons are, you know how to use them, you see that log and ln are different things. And on 1 through 5, I want you to notice that something weird happens on problem 2 and problem 5. So I want you to pay attention to that. Okay, so when we do the log of 0.25, I'm going to round to 3 decimal places. we get a negative 0.602. But when we do the log of 0, and you should go ahead and try it, it says domain error. See, this is undefined, and it has to do with the domain of a logarithmic function, which you'll see better later. When you do log of 1,000, it is exactly equal to 3, and you'll understand that why later, once you know more about what a log really is. See, logs and these exponential functions are related to one another, kind of like adding and subtracting, kind of like squaring and square rooting. They undo each other. So this log is like the name of a function. When you're looking at it, it's like a name of a function, log. And whatever index it is belongs as part of that name. And then you've got your input, and your input of 1,000, when you perform that process, spits out 3. I need you to understand that, because I need you to see that log of 1,000 isn't log times 1,000. It's function notation. And so you do it or think of it just like if it were f of 1,000, okay? It's just that f wasn't anything special, any special rule, where log really is. All right, let's just finish these up. If we do natural log of 3, you get about, it's an estimate, so I'm going to use the little squiggles, 1.099. And then when you try ln, make sure you're doing ln and not log. If it says ln, you got to do it. Okay, if you do the ln of a -6, you see how it gives you a domain error? Okay, what that kind of tells you, gives you a sense of, is that you can't put a 0 into a log, and you can't put a -6 into a log. They can't be inputs to logarithms. So you know what the domain? Okay, the domain of a log function like this, or this, okay, or any type of log, like not just base 10, but base 3, base 2. The domain of a log function like one of those is going to be a little bigger than 0 to infinity, okay? Not allowed to plug in 0. You're not allowed to plug in a negative number. All right, now all of these over on the right, these are all exponential. And so to do these, I used the base E for some reason on all of them. And so you need to find that key. So you should be looking at where your ln button is a lot of times. It's just going to be contained right above it like that. And you access it by using your second function key. Okay. And so what we're going to do is we're going to type it in, and it's going to look like that. When I do mine, second function, and the e to the x button, it does e raised to a power, and then the power would be 4. So I'll put that in. And then I hit enter, and I get my answer, and it turns out to be around 54.598. It's about 54.598. Now, rounding can be a bit of a problem if you don't know how to round. So let me just show you that this one was 59815,003. A lot of times you'll be rounding to like the thousandth or 3 decimal places. So do you remember how you look after it? And since what's after it is a 1, that means this number is closer to 54.598 rather than 54.599, okay? All right, and so then we did some others. So if we do e to the negative point, let's try that one. If we do e and we raise it to the negative 0.12 power, and watch the zeros, make sure you've got it really typed like it is. It's decimal 0.12 and the decimal is negative. Can we do e raised to a negative number? We couldn't do that with log. But sure enough, we don't get a domain error. We get 0.887 if we round to 3 decimal places. Okay, e to the 0 when you do it, it's 1. But that's because anything raised to the 0 power is 1, except 0. Okay, and then if you do e to the 0.085, we wind up getting about 1.088, 1.089. And then you can do e raised to a fraction. The only danger on fractions would be if your calculator doesn't prompt you with the parenthesis. Because like I use division to do my fractions, so I type it in like that. Some people use the fraction key on their calculator. Either way is going to work. And if you did that right, it's going to turn out to be about 1.396. Okay. All right, this is where I want to stop on this video. I like my videos to be as short as I can make them. And then we're going to pick up where we left off in the next video.